Lesson 24, day 1, 3-4, interpreting graphs. We're going to talk about different types of transformations. And transformations are simply changing the size or the position of a graph or an object. We have two different types of transformations that we'll talk about. One being a translation. A translation is simply a slide of a figure. Each of the points on the graph or object would move in the same direction and the same distance. A reflection is another type of transformation that involves flipping a figure over a line, and those lines normally would be the x-axis or the y-axis. It's just simply a mirror image. Three other vocab words: max, min. Max, it is what it is. It's the highest point on the graph. A min would be the lowest point on the graph. Zeros of a function. What you need to know about zeros of a functions. Basically, it's a value of the independent variable that makes the dependent variable 0. In other words, it is your x-intercept. So where it crosses the x-axis. Zeros are where the graph crosses the x-axis. In this unit, everything's focused on nonlinear. So all these nonlinear functions, not straight graphs, we're going to go ahead and kind of dissect them a little bit. This is the absolute value graph. When you have a negative out in front of that absolute value, it's not going to create that V-shaped graph. It's going to go ahead and actually reflect it. So it's going to flip it, and it creates that V upside down. So you have negative absolute value x plus 1 plus 3. You need to go ahead and state the max of the graph. The max would be the highest point on the graph, and this does have a highest point. The highest point to this graph is right here, which would be 3. So height is along your y-axis, your vertical axis, so it would be 3. The min of this graph actually doesn't have a min. The reason why it doesn't have a min is because this graph goes on forever and ever, and it would keep going down, down, down that graph, so the min here is going to be none. Estimating the zeros. And again, it's an estimate, so it's an approximation. That's where it crosses your x-axis, and this graph crosses my x-axis here and there. So negative 4 and 2 would be my two zeros. Increase and decrease. I like to go ahead and use my graph to show that increase and decrease. You can see where the graph is increasing and decreasing. So when you read a book, you read it from left to right. So this, we're reading our book, and this part of my graph shows the increase. It increases to this point right here. So I'm going to bring this guy down here. This is showing the increase of my graph. And this graph goes on forever. So I could start this line way back here. So it's increasing from negative infinity, your x value, all the way up to negative 1. And that shows the increase. So we continue past that, and it's going to show us a decrease. So from this point right here at negative 1, this graph starts to decrease. From negative 1 all the way out to positive infinity. The reason why positive infinity, that graph goes on forever and ever. So that would show us the decrease of the graph. Cubic function, x is cubed. That's what our graph would look like. Again, max and min here. The max of the graph, the min of the graph. And actually the max and the min for this graph is going to be none. The reason why that is this graph goes on forever in both directions. So you're not going to have a maximum value or a minimum value. So that's simply none. Estimating the zeros, again an estimate. So an approximation, it's where it crosses your x-axis. And in this case I see that it crosses slightly below negative 4. So I'm going to say that it's approximately, I don't know, negative 3.8. That's one of my values. And then again, it intersects at that point. So that looks like negative 2. It looked like I was right on negative 2. And last, my 0 is slightly below 1. So I'm going to say it is 0.9. Remember, estimating the zeros are where it crosses the x-axis. Last but not least, our increase and decrease. Again, when you read that book here, you're reading from left to right. We hit that graph, and this graph shows us right away that it is an increase. So from negative infinity, because the graph goes on forever, it shows us an increase, and it increases all the way up to this point right here. I bring that down. Looks like it increases from negative infinity to negative 3. Then once it hits that negative 3 value for x, it takes a turn and it starts to decrease. So this next part of my graph is going to show a decrease, and it's decreasing from negative 3 to this point right here. That point right there is slightly below 0. So I would say that it looks like it could be about negative 0.2, and that's going to show us a decrease. From negative 0.2, which was right there, it's going to rebound back on the increase, and it goes on forever and ever in that direction. So from negative 0.2 to positive infinity, the graph is going to increase. This will conclude Lesson 24, Day 1